Hello, good evening. Yes, we'll start. Yeah, we'll stick to the timelines. And today is the second open session. This is the course started yesterday itself. So tomorrow will be final open session, and we'll create a group and WhatsApp group. And yesterday only one student wrote answer and sent me. Why so? Try to write the answers, especially students who took admission. So I will correct and based on that we will see. Anyway, so tomorrow also we'll have one more open session and then see how it will work out. Fine. So we'll very quickly revise yesterday's class. Yesterday's class ఒకసారి quick గా revise చేసాము. No time. No, you have to make time. Only one answer, na? You know how much time you will get for 10 marker? 10 minutes. If it is UPSC, it is 7 minutes only. Okay, so 7 minutes you have to make. Don't spend 1 hour, half an hour to write the answer means try to stick to the time initially, and slowly initially it will take more time. Slowly you have to stick to that 7 minutes or 10 minutes according to your examination type. Okay, so what did we do yesterday? We just started with space. Okay, what are the various orbits? Low Earth orbit, medium Earth orbits, and see why these things are more dense here, and what is the speciality of this single orbit here, geostationary orbit, where you have more satellites. Okay, like with this we started yesterday. Why satellites are there, why the timeline is different in 1 month only, why Earth is covering this much of distance, whereas for 3 months it is only covering this much small distance here. The difference we saw. Gravitational force we saw, force of attraction, balance forces also we saw. How a satellite move also we saw. Perigee, apogee, and all these things we saw yesterday. This is the explanation for centrifugal force and centripetal force with the velocity moving. The Earth will not fall, or a satellite will not fall because of its velocity, due to which another force is coming into picture. That also we saw. So orbit need not be only circular, it can be elliptical also. Okay, in elliptical orbit it is there, one of the points Earth will be there. Orbit of the satellites can be like this also. Fine. So once it is away, as I said, the speed of the satellite will be slow. Here the satellite will be very fast. What will happen when it is slow here? When the satellite is moving very slowly here, it can observe the Earth. Basically, it can observe the Earth, right? For more time, it can observe the Earth and get recordings. That is the reason we are having this so much of elliptical orbits. Okay, in order to say that we can observe here, the satellite will go very fast, so much data may not be collected here. It may be nearer, but it is going very fast now. Okay, here it is slow, so it can image. Here also, when it is nearer, more images can be collected, like that. Both applications can be there, farther and nearest end, like this. Okay, so we saw types of orbit. We saw in 3 dimensions: orbit types, then launch vehicle types, satellite types. Types of orbit to launch vehicles in Indian context to type of satellites too. All are interrelated. That also we saw. Polar orbit or sun synchronous. Why it is sun synchronous also, we saw it yesterday. Right, because it is facing the sun always. Then why it is geosynchronous or geostationary Earth orbit, like that. Okay, a special case of geosynchronous orbit. A special case of geosynchronous orbit. Special case is geostationary. Okay. So we will start the class as far as possible. We'll start the class exactly at 8:81:82, and I will revise the previous class. Okay. All the newcomers, if there are any, don't think that I am going fast. Okay. It's because it is yesterday's class. Is my volume okay? Am I audible to everyone? Am I audible to everyone? Bolo? Yes, yes, audible. Just please check your internet connection. Okay. Fine. Thank you. Thank you for responding. Yeah. Here. So we are revising only yesterday's class. So that's what we are doing. And this, all things we saw, type of communication satellites, INSAT series. What are the applications of communication satellites? Like type of satellites, based on their applications, we are differentiating them, in which orbit they are there. So GSAT and INSAT series are communication satellites. That's what we saw yesterday. Whereas other type of satellites is Earth observation satellites. Second type. Second type of satellite is Earth observation. In Indian context, it is also called as remote sensing. Look at the applications of this. This applications is different from previous applications because it will go very fast. In which orbit Earth observation satellite will be there? Answer. In which orbit Earth observation satellite will be there? In which orbit Earth observation satellites are launched? Okay, polar. No, Sana, it's not geo. It's there. Some people are doing mistake. Okay, polar orbit. Earth observations are in polar orbit. Based on that only, they can rotate. Yeah, Earth is there. They have to observe multiple times. They have to observe and do mapping, images, all these things they have to do. Like that, we saw examples of these things also are there. Gagan and IRNS, Indian Regional Navigation System. At global level, you have GPS. Our own Indian version is this. We will see actually this in detail tomorrow. Okay, how this is installed, because prelims questions can come out of this very important thing. Okay. So like this, launch vehicle types also we saw where they are designed. Vikram Sarabhai Space Center. Tomorrow, I'll display questions. Whatever we have done, because it is just one class yesterday, I didn't display prelims questions. I'll display that also. But anyway, it's not that daily one mains answer we'll put initially, but every weekend we will have a complete dedicated to questions. That is also there. Anyway, as a trailer, tomorrow we'll have questions. So revise today's and yesterday's class. Based on that, we'll have questions tomorrow. Okay. So like that, Liquid Propulsion Center, all these things we saw. Satish Dhawan Center, where rockets are launched. Okay. Fine. Types of rockets. We will see those things in detail. Don't worry. Here today, this is the development of stage 1, stage 2, third generation, second generation, like that. Now we are using this 3. Fine. PSLV, GSLV, Mark 1 and Mark 2. That's what we are. We also saw that PSLV is not only used for polar orbit. It is also used for geosynchronous also. Whereas GSLV is used for both geosynchronous. Sorry, GSLV is used only for geosynchronous transfer orbit or geostationary orbit, whereas PSLV is used for both. Okay, we are hugely dependent on it. Fine. So that's right. Now, this is still this point we did yesterday. I asked some questions. No, my dear Jaber, not required. See, the things will not be so much factual. Once upon a time, the question is, do we remember to importantly note down specifications of every satellite? No. Okay, look at the last year and this year launches that we will do in current affairs anyway. It's not that if they are last year launches of they're important. If there is any significant development, then only they will ask. Actual things are going. Group 1 are also turning more applied. Okay, 1 or 2 data pointers may come, that we have to leave it. For that, we can't change our orientation. So much of data overloading is not the purpose. It is just a trick to make you do mistakes. Okay, so no need, not required. Remembering. Now we will see these things in detail. we will see the launch vehicles in detail. That's what we have to see, at least these two. So first one is Polar Satellite Launch Vehicle. As the name says, it is for different versions, my dear. Don't worry. We are going to cover GSL Chandana. We are going to cover those two types. That is not yet done. Till this was yesterday's class. Now we are going to start today's class. Okay, that was only revision of yesterday. Now we have to doing Polar Satellite Launch Vehicle. So PSLV, as I discussed yesterday, for polar orbits as well as geosynchronous transfer orbits. Okay, for both it is launched, but mainly for the purpose of polar satellite. This is third generation. We are calling this as third generation launch vehicle because, as I said, it's developed through various stages. India's space program developed through various stages. So third stage is PSLV. Fourth stage is Mark II. Then the next generation is Mark III, GSLV Mark III. Okay, first launch pad vehicle used with liquid. This is very important. Liquid stages. In the previous two stages, this is the third stage. In the previous two stages, liquid propellant. What is a propellant? Propellant is a fuel. Okay, generally solid fuels are used before. Okay, it will burn and it will create exhaust. Why? See, what is a satellite and what is a launch vehicle? As we discussed yesterday, this is the here you will have a satellite which is called as payload. This is also called as payload for the launch vehicle. Everything is launch vehicle. So it will have different stages and it will have fuels. The fuel has to be burned because I said there is Earth's gravity. We saw basics of gravity also yesterday. Some great force is pulling the body mass. Okay, in order to go away from the gravity of the Earth, the fuel has to be burned and exhaust will come. Then it will move up. Okay, so the fuel generally in the first two stages are solid fuels. But PSLV started for the first time using liquid stage. That's what first launch was in 1994. Okay, we call it workhorse because consecutively 39 successful launches were there. PSLV is so success rate is very high. Till by June 2017 means it's not that after June 2017 we are not using it. No, we are still using it. There was a mission failure in 2017. So till that time, from launching time 1994 to this time, 39 successful missions it has done. Very high success rate. Okay, and it is very important for us PSLV because it has been used for Chandrayaan for exploring moon, Chandrayaan 1, and it is also used in launching Mars orbiter mission, MOM. 2013 Mars orbiter mission was launched. In 2008 Chandrayaan 1 was launched. 2008. So for 1 and MOM Mars orbiter mission we used PSLV only. This can be a prelims thing. Okay, Chandrayaan 2 didn't use PSLV. It used GSLV. Okay, vehicle which we have to use. Okay, so these are the basics, very important things only I have kept. Fine. So that's what we have to see here. Now coming to the main things, very important basics which we have to learn here. See, listen, this is a basic specs. Don't just see, just observe once or twice. It's not that you have to remember every parameter, just observe, right? Stages, it has 4 stages. When I say stages, I am talking about stage 1, stage 2, stage 1, stage 2, stage 3, stage 4, like that. Okay, that's what I am talking about. Fuels will be there. First stage is solid fuel. Second stage is liquid fuel. Third stage is again solid stage. Fourth stage is also liquid stage. And the fifth, and there is no fifth stage here. And this is payload. This inside it you will have satellites. Very number, not even one satellite. There can be many satellites also. More than 100 satellites are also being launched by PSLV at a time. It's not that only one payload will be there. One satellite will be. Multiple satellites can be launched. This is the way it will be. So 4 stages you have. At the initial stage, you have
strap-on motors. That's what written here. It's a kind of boosting kind of things. So this is the overall configuration of which launch vehicle? PSLV. Starts with solid, liquid, solid, liquid. And that's what we are using. That's the reason we are seeing 4 stages. So it has 3 variants. The variants are there based on strap-on motors. Okay, PSLV-G, PSLV, core alone. CA means core alone. CA means what? Core alone. Core alone, as I said, means no strap-on motors. What are strap-on motors? See, basically here, it will burn. It will burn and it will lift off. So at the initial age, these strap-on motors will supplement the boost. More push it will give. Okay, like in the initial stages of your preparation, you require more push. Na? That's the reason we are asking right answer, study, study, study. Now, because inertia will be there, you will not be studying. So at the initial stages only, that push is there. Once you are into the mode, you will study on your own, like that. That in the just an analogy. Okay, at the initial stages, the strap-on booster motors are there to push more, to give more thrust, to give more force. Now physics will come into picture. That's the reason, leave those things. Okay, so that's the reason strap-on motors are added. Now PSLV uses how many? 6 liquid, solid, sorry, not liquid, 6 solid rocket strap-on motors in the first stage in both variants. Okay, PSLV-G and PSLV-XL variants. Whereas no strap-on motors are used in PSLV-CA. CA itself means core alone. Okay, that's what here, CA, PSLV-CA. 3 variations. Then if they are using 6 solid rocket strap-on motors, then what is the difference between PSLV-G and PSLV-XL? Anyway, PSLV-G and PSLV-XL both are using strap-on motors. Only 6 numbers they are using. The capacity is different. 9 ton, 12 ton, like that. Both are using 6 strap-on motors only they are using. Their capacity is different. XL is using higher capacity motors, like that. Okay, so this is the basic understanding which we have to add. Solid, liquid, solid, liquid. And very important thing is, in this liquid stage, we are using a very indigenously built engine called Vikas Engine. The name of the engine is Vikas Engine. Fuel has to be burnt. Fuel has to be burnt with an engine. So we are using this Vikas engine in the second stage. Okay, so that is what we have to know about PSLV. Some important points. Quickly ask anything if you have not understood. Okay, anything you have not understood till here? Okay, fine. Then we go to the other important dimensions of PSLV. What? Please explain what polar satellite launch vehicles, Sveta? Were you there yesterday? Core alone. Acha, you want core alone. In core alone, we are not using this strap-on motors. Extra motors here there. If you see, these things will not be there. All these are the extra motors. You see here, these are the extra strap-on motors. These things will not be there in PSLV core alone. Only these things will not be there. Okay, only the stage 1, stage 2, stage 1, stage 2, stage 3, stage 4. Only these things will be there. Whereas on PSLV G variant and XL variant, you will have strap-on motors to give more boost for the launching of the vehicle. Okay. No. Don't come to that. Don't come to that conclusion, Jabir. It's not done that. Okay. Vikas Engine is a indigenously built engine. The name of the engine which burns fuel in the second stage. In the second stage of PSLV, the second stage of PSLV will use Vikas Engine. The name of the engine used in second stage is Vikas Engine. It is indigenously built by India. We didn't import from other countries. Okay, we have built that engine. That is its specialty. The name of that engine is Vikas Engine. Okay. Fine. Strap-on motors, add-on motors to give more thrust. That's what I am saying. Fine. These things. Without these motors, the thrust or payload capacity, the amount of satellites which the rocket carries, or the amount of distance the rocket can go. Because more thrust means then only it can go into the more distance orbits, like that. So either it may, if you remove strap-on motors, either it will affect the weight of the satellite, which can it carry, maximum weight, or it can also affect the distance through which it can go. So orbit 600 kilometers, 500 kilometers, higher or lower, or these things will be affected by addition or removal of strap-on motors, like that. Now, if you see some more points with respect to PSLV here. So generally it is used for delivering low Earth orbit satellites. It can take up to 1750 kgs of payload to where sun synchronous polar orbit. This we saw yesterday. Polar orbit is called sun synchronous polar orbit. 600 kilometers, up to 600 kilometers altitude it can. See, if you decrease the payload, this distance will increase automatically. Okay, for 1750 kg weight of satellite, this is satellite weight. Don't consider that this is the weight of a whole rocket. Whole rocket will be much more higher because lot of fuel is there. The weight of fuel itself is very high. Fuel weight is very high. Okay, we are talking about satellite weight, and that's the reason it is called payload. Okay, so as PSLV is so successful, we have used this thing for geosynchronous orbits also. That's what we explained yesterday also. Okay, now second important thing is second. Yeah, thank you. Second important thing with respect to other type of vehicle which we have is GSLV. GSLV, geosynchronous launch vehicle. As the name says, it is used for which orbits? We saw two types of orbit yesterday. Okay, one is sun synchronous, other is geosynchronous. Okay, so for this orbits, we have a launch vehicle called GSLV. GSLV. Okay, it is obviously the fourth generation because fourth type, first one, second one, third one is PSLV, fourth generation is GSLV. It has 3 stages. Unlike PSLV, which has 4 stages, okay, GSLV has only 3 stages: solid, liquid, cryogenic. Cryogenic. I will explain this in detail. What is this cryogenic? So basically it has 3-stage vehicle. Okay, and it has also strap-on motors. How many strap-on motors? 4 liquid strap-on motors. Why I am saying, see, motor is a motor. Whether here you will have solid, identify the difference. All these are the question points. Here you have solid. In PSLV, solid strap-on motors you have. Means the fuel which is being used in these strap-on motors also will run because of fuel. That solid fuel only we are using. Whereas in GSLV, that strap-on motors are also liquid. Efficiency will be higher in some aspects like that. Okay, so strap-on motors are also liquid. That's what we have to use. So the cryogenic engine. What is the meaning of cryogenics? Anyone? What is cryogenic? Bola? What is cryogenic? None. Cryogenic means low temperature. Study this we are talking about, not cold, very low temperature. Very low temperatures. Like we saw in one of the sessions, in superconductivity session last week, when she has found very low temperature, it will be minus 100 degrees centigrade, even lower, minus 130 degree centigrade, like that. It will go on. Okay, so this is called low temperatures. It's not that it will be only after minus 100. It's not like that. On Earth also, if you are on Earth, all this Arctic, Antarctic, third pole, which is called Himalayas, ice glaciers will have. All that is also called cryosphere. Yes or no? Cryosphere, we call it on this Earth. When you have ice formation like that, low temperatures. So in the same way, this third stage which you are using, it has a cryogenic stage. third stage, upper stage. We are calling upper stage because first stage is, if you take this rocket launch pad, this is rocket launch vehicle, solid, liquid, and third stage is cryogenic. Cryogenic. Third stage. That's the reason last stage, upper stage, we are calling. Okay. So because of this cryogenic, the capacity is increased more than 2 tons, up to 2 tons. Previously, it is lesser. Now it is 2 tons because of GSLV. So GSLV is mainly used for launching which type of satellites? Communication satellites. I already told PSLV for Earth observation satellites. PSLV or polar orbit is generally for Earth observation satellite. This we did yesterday. Whereas geosynchronous orbit is generally used for communication satellites. That's the reason each class is important. Okay, if you have missed it, try to refer these concepts. You will understand why this is so. Okay, so GSNV is generally used for launching communication satellites. Next variant, this is called Mark II, version 2. Third stage is called Mark III. Sorry, next stage is called Mark III, MK3, because we have more capacity booster rockets, strap-on rockets here. Leave it. Okay, so it has 3 stages you have. Now, when we are talking about GSLV, it has 4 liquid strap-on motors. See, this is GSLV. GSLV. In GSLV, what is happening here is, all these are strap-on motors. They will have 4 strap-on motors. 1, 2, 3. Other side is 4. Okay, this is not the actual stages of the things. Just they are motors. They will boost. They will give more thrust. They will give more thrust for the thing to go. Okay, so first stage, apart from this, all these 4 stages are based on what? Liquid stage. Okay, so generally we are calling about GSL means we are talking about Mark II, version 2 kind of things. Generally. Okay, then it will have 3 stages. Apart from this 4, you have 3 stages. First stage, second stage, third stage. These are the 3 stages. This is the payload. This is the satellite. Payload. Okay, third stage is cryo. Second stage is liquid. First stage is solid. All these strap-on motors are also liquid. Like this, don't get confused. Stages are only 3. Strap-on motors are made up of liquid things, extra additions. Okay, in the second stage also, Vikas engine is used. So where liquid, because second stage is also liquid. Second stage in GSLV is also liquid. Yes or no? That's the reason in liquid stage, we are using which engine? Like in PSLV, we are also using Vikas engine in GSLV also. So don't get confused. Don't get confused. Yeah, extreme coldness. Don't get confused that PSLV is only using Vikas engine. No, my dear, not at all. Okay, and very important thing is saying in GSLV, we are using Vikas engine also. And in strap-on motors of GSLV also, we are using Vikas engine. In strap-on, because strap-on motors are also made up of which? Strap-on motors are also made up of liquid strap-on motors. There also we are using Vikas engine. So Vikas engine is used in, if you look at Vikas engine is used in PSLV second stage. Then GSLV second stage. And also GSLV strap-on motors. All these 3 areas, Vikas engine is used. Okay, so that is the things is there. So the cryogenic engine, low temperature engine developed by this GSLV is developed by Liquid Propulsion Center. Comes under ISRO. Obviously, all this comes under ISRO. The name of the center is liquid propulsional cylinder. First cryogenic engine that got developed. From then we are using this in all GSLC LV launches. Fine. Now, if you look at very quickly, it's not that every. No, my dear Nagaraju, that's a difference. Actually, I planned to ask that as a question. In the fourth, anyway, you have asked it. If you go back to fourth stage, in this stage, we are not using Vikas Engine. Okay, in only second stage, we are using Vikas Engine. Okay, so if a statement comes, all liquid stages uses Vikas Engine. No. Okay, only in the second stage, then in GSLV second stage, then in GSLV strap-on motors, we are using Vikas Engine. Okay, fine. That's what we have to observe. Good. Then, with respect to cryogenic upper stage, forget about all the data. Hindu will give many things. We have to see here what is this cryogenic fuel is using in this. What are the fuels used in the cryogenic stage? For that only I have. But this is GSLV Mark III. So look at the difference. These booster strap-on things. It will use S200 boosters. So much of big boosters are there here. Look at this booster stages. Okay, unlike small booster rockets here in GSLV Mark II, we have very big boosters in GSLV Mark III. Okay, that is what. Here also in GSLV Mark III, same thing, solid stage, liquid stage, cryogenic stage. Okay, the same thing will be used. Second stage will use Vikas Engine, no doubt. Okay, but main things is there here. What is the fuels which are being used in cryogenic stage? What are the fuels they are using? Look at this. Look at the temperatures here. Oh my God, minus 253 degree centigrade. So low temperatures. So low temperatures, liquid hydrogen. Because hydrogen will be liquid only such lower temperatures only. Okay, room temperature, water is liquid. Higher than 100 degrees centigrade, water is gas. But hydrogen is like that. So in order to make hydrogen, you have to reduce the temperatures to very low. Okay, so in cryogenic stage, we are using liquid hydrogen and liquid oxygen. Okay, both when oxygen is there, combustion will happen. Burning will happen. Both will burn, liquid oxygen, liquid hydrogen, they will come together, burn, thrust will come. This burning will come. Okay, then they are also using helium liquid also. This is prelims. Not as a fuel, in order to maintain pressure in the cryogenic chamber. So the cryogenic engine uses three things: liquid, hydrogen, if I may write, liquid, oxygen, and helium. Liquid, helium. All are in liquid stages only, my dear. Because low temperatures are there. Liquid, helium. This is not as a fuel. This is used in order to maintain pressure in the cryogenic chamber. Okay, that's what they have raised. Okay, so a lot of insulation is required. That's the reason problems are mentioned here. It's okay. See, we are going. Look at the beauty of the vehicle. The vehicle is going at a very high speed. It is going into the atmosphere. You have atmosphere. It is bursting into it. Lot of pressure will be there here. Lot of heat will be there here. The temperatures will be very high temperatures on the outside of the rocket or the launch vehicle. Very high temperatures outside, because a lot of burning is there. We are creating a materials. We are making the rocket such that it will not burn. Like that insulating materials we are using, so that it will not burn. But high temperatures outside, inside we have very low temperatures. That is the speciality of this cryogenic. Okay, so that is the description we have. Okay, Please make videos in YouTube. No, my dear, join the course. I'll support you. Strap-on motor with liquid only. No, Raju Nayak. Strap-on motors. Why many are asking on YouTube? This is not like that. We will limit to the course. Some open sessions we'll keep regularly. Okay. No, Raju Nayak. All strap-on motors are not liquid. In PSLV stage, the strap-on motors, if you go back, in PSLV stage, if you see in the PSLV, the strap-on motors here, they are not liquid based. They are solid based only. Na? I repeated this also. Okay. So in GSLV, we are using liquid stage in both GSLV Mark II and Mark III. Fine. So this is there, liquid helium, all these things are there. This is the crux, not the data. We are looking at the analysis kind of things here. That's the beauty with respect to cryogenic stage. Outside, very high temperature, but inside, very low temperature. We saw the temperature so low. They are so low. Very so low temperatures are being maintained. बहुत बढ़िया. अब देखो. Now, the actual another concept, we saw PSLV. We saw GSLV. Now we will see how the rocket, the launch vehicle, how it goes. Each stage, it will be separated from the sea. In the first stage, Sriharikota is the launch pad. We have Satish Dhawan Space Center, where we launch these satellites, to launch vehicles and all these things. It has payload. Okay, it is launching. Each stage, as we go, if you see in this figure, if you see, each stage is breaking off. See, it got broke off. After the fuel is burned, strap-on motors will go. First stage will go. Then second stage will go. Look at the size of the rocket. It is decreasing. Big rocket is becoming small. All the strap-on motors went away. Okay. Then another part goes away. Then third stage also goes away. Only satellite will remain in the orbit. Remain alive in the orbits. Orbit or orbits. Because I said multiple satellites can be launched. Okay. Orbits or this is the way. So each stage it is going away. So ultimately, what is remaining? Only satellite. Okay. So the whole vehicle is staged by strap-on motors here, booster rockets, whatever. Whole vehicle is being destroyed. Na? Each stage it is gone. Once it is lost, why it is not falling in Ashoknagar or in somewhere? God forbid, nothing should like that happen. When the stage is there, it is left in the space. Na? Okay, it's not like that. The Earth, it will enter the Earth's atmosphere. The Earth atmosphere will burn it into spark. Spark will come. They will just get destroyed. Okay, debris will be forming. Fortunately, they will take care of those aspects. Don't worry, you are safe. Now, like this is there. So, is this PSLV or GSLV? What the GSLV also same stages, stage by stage. Everything will be like that. Is it reusable? Can we use it, these things again and again? No. They are like use and throw. Yes or no? China pieces. See, I'm not derogating it. I'm just giving. Once upon a time, China means use and throw. Now China became advanced. That's a different story. So these rocket vehicles, these rocket launch vehicles are not reusable. They are not reusable. That is the difference we have to understand. Okay, they are not reusable. So if you want to launch a satellite, again you have to build the PSLV. So different names we are giving. C51, this one, that one, time, number we are giving that. So every time you have to build the PSLV. If you have to launch a satellite, every launch you have to build the PSLV. Fine. It may become space debris also. If it, see, what if it falls? Am I installing it? How can you say that it can become only space debris? Is there any guarantee? Some of the students are saying it will become space debris only. Why? Okay, if the rocket is left off in initial stages only, it is not being launched with a velocity. Na? Is it launching with a velocity? Is there any guarantee that it will stay in the space? Yesterday only I discussed it, na? In a particular orbit, if you have, let us say, in a particular orbit, if this is there, Earth is there, in this particular orbit, if that velocity is there only, then only it will stay. Who is giving velocity for all these things which are broken away? They are just falling. They may stay in the space, they may fall on the ground, anything can happen. Okay, if it is going, if the stage is separated at a very far distance, thousands of kilometers from the Earth, then it may not reach the Earth, it will stay in space as space debris. Okay, there also limitations are there. Okay, so like that. If it falls also, don't worry, it will be taken care of. Atmosphere is there to protect us. Now, here, if you look at this stage, now Pslv, it is not reusable. GSLV is also not reusable. Yes or no? PSLV is not reusable. GSLV is also not reusable. But look at this USA. This is the space shuttle of USA. What is the difference you are seeing here? You will feel as if an aircraft is there. Yes or no? All these are the fuel tanks. This one, boosting rockets, and this is the space shuttle, which they are calling it as space shuttle. Only the fuel tanks will go away. See, look at the fuel it is ejecting. I am giving an example of USA. This will go, launch the vehicle, this vehicle will go, launch the satellites, and can go to space station, because there is a space station, International Space Station, which is roaming around the Earth. It can go there, launch it, deliver the astronauts, and come back also. It can come back also. That's the reason this is a reusable launch vehicle. Once it is built, there is no need for us to, for every satellite, you need not to construct a launch vehicle. No, not required for every satellite. It will go, it's like just like an aircraft, just like our Indigo airplane, taking the passengers and delivering at other point. These spacecraft, these kinds of reusable launch vehicles can deliver the satellites into the orbit and come back. Okay. Sir, if all the fuel is lost, see here also all these fuel tanks will be lost while it is launching. Then how can it come back? Fuel tanks are gone, na? Then how can the vehicle come back? I said it is reusable. Reusable means it has to come back, na, and come and land like an aircraft. Then only we'll reuse it again and again and again for next launch. I said that this aircraft will go. This is the main aircraft. If you observe, it can go, launch in orbit and come back. Fuel tanks are not there, na? How it is going to come back? How it is going to come back? First answer my statement. My question you answer. Why? How can it come back when all the fuel tanks are being launched or lost? For coming back, it does not need fuel tanks, no, not completely. A kind of fuel is required. The main answer is gravity. Earth has gravity. Fuel tanks are required. Fuel tanks are required because from Earth we are going away. So Earth is pulling us, gravity. In order to push it, we want to see so much of push is required. We require so much of big fuel tanks. But while for coming back in orbit, this is the orbit, suppose. Okay, satellite, this aircraft is there here itself. This aircraft is there here itself. Like this aircraft is there. So it will reorient itself. So definitely for reorientation, it also has, if you observe deeply here, there are also ejection points for this also. It will have fuel. So don't say that no fuel is required. So it will change the direction. It has to change the orbit. Na? Then it will slowly maneuver itself. Slowly it will maneuver and come and land. Like that. In fact, direct landing will not be there. They will take a specific path, actually, like this. Okay, if directly dhoom bolke means it will come and hit, the Earth will pull it. So they will change, they will continuously change the orbit and slowly they will come and land in a particular place like this. Okay, I have drawn a very diagram. See, the intention is here. If you want to clearly understand how it will come, Earth is there. Here you have a plane here, aircraft. You have, it will slowly change the direction with this fuel. Small amount of fuel only will be there. Then slowly it will come and it will try to land like this. Every time it is changing the orbits. Okay, that is the way it is being done. So India does not have a reusable launch vehicle. Why India is then? It will, I said na Nitin Yadav, without having fuel tanks, how and from where it will use fuel. Array, it is an aircraft, na, like aeroplane, my dear friend, like aeroplane. Aeroplane also has fuel tanks. Are they visible outside? No, na. In the car, you have a fuel tank. Is it visible outside? No, na. Inside it will be there. So less fuel is required. This carries that fuel within it. Okay, understood? समझ में आया? Any, see, don't get hesitant to ask doubts. Maybe, see, we are also, there is no much age gap here. It's not that I studied one particular subject and I want to try to deliver it in a simple manner. So don't take it personally. We can do it. If you are getting some scoldings, not scold, if you are getting some scoldings, you will never forget it. In the examination, you will not do that mistake. That is the intention. What else is required? So do as many mistakes as possible now. Don't do it in the exam. Okay, very good. Fine. Now, going back here, yeah. So India does not have a reusable launch vehicle. We have an experiment we did. We didn't develop that till now because we developed this PSLV technology, GSLV technology. They are working for us at very low cost. This is an advanced technology which we didn't have till now. Till now, we didn't have that advanced technology of reusable launch vehicle, but an experiment has been done by ISRO, our space agency. ISRO conducted an experiment with respect to reusable launch vehicle. Okay, so fully reusable launch vehicle to enable. Then with PSLV itself, we have low cost launches. Imagine the cost once we have reusable launch vehicle, the cost will further come down. Very low cost we will have if we are able to have this technology. Because already the specialty of ISRO is able to launch vehicles at a very low cost when compared to other countries of the world. Once we have this technology, definitely the further cost of launching satellites into the space will come down much lower. So it's a very great leap. That's the reason we did that experiment is done by ISRO. Okay, that's the reason it is called, if you observe here, RLV means reusable launch vehicle, TD, technology demonstrator. T means technology demonstrator. Only experiment only it did. Completely we are unable to not do yet. Okay. So what they did was, see, in reusable launch vehicle technology demonstrator, they have launched it with the help of a rocket here. The rocket will be lost here. See, this is the thing which was able to push. Initially, it was able to push this. It is just like an aircraft, if you observe. It is like an aircraft. See here, like an aircraft. In previous thing also, like an aircraft, like USA thing. It showed on this Bay of Bengal, we did this experiment. So it stayed there. Then again, it re-entered and landed in a hypothetical manner. So the going and coming back, that experiment only, because it will go at hypersonic speed. Hypersonic means more than 5 Mach. Mach means speed of sound. This we already saw in the previous session. So that high speeds, it has to come and come back. That is the intention. It is only experiment we have done. So experiment was done successfully. In the future, reusable launch vehicles will come for us. If it comes, it will be a great leap for India's space program. Okay. So yesterday's question, quickly we will review that. That's a different thing. Biswas, I will cover that later. What doubt you are asking. Okay. First, we will do Indian things. Then we will look at SpaceX and NASA. Why SpaceX was able to do it very low cost. Definitely, it used the technology which was not done before. This vertical launching was done by SpaceX. But anyway, come back to us. First learn about our program, then we will see that anyway. No problem. Now here, yesterday I posed a question, why these rocket launch pads are on eastern side? On eastern side, why they are located on the east coast? Why they are located here? Because first thing, and nearer to equator also. Nearer to equator also we have launched. Here we have launched it. For America, it is in Florida. Florida will be there. Why America has to put it in New York, Washington, DC, New York, which are at upper level. More cities, more scientists will be there. It didn't keep. If you see USA, if you draw USA like this, Florida will be there. Here, edge, on the edge of USA, this is USA for your information. Here you have their launch pad. Okay, the reasons is near the equator, gravity is low. So the satellites can be launched easily. Okay, that is one thing. Then if that is the case, and second thing, why on east coast means Earth is moving from west to east. The Earth itself is moving from west to east. So if you launch from east side, the eastern direction of the Earth will help the satellite. Just like you are climbing down from a bus. This is the bus which is going, and you are doing footboarding. You are jumping. You have to go, if you jump in the direction of the bus slowly, it will be easier for you. If you go in the reverse direction, force of opposition will come, like that. Okay, so when Earth is moving from west to east, the eastern way towards east, the Earth is moving. So if you launch the satellites towards east, it will be very helpful for their easy launch. Okay, if near to equator is the criteria, those are the two important criteria for looking at why satellite launch pads are located on the eastern side. If you look at that case, equator is not passing through India. Of course, it is nearer, 8 degrees, so we are away. Then you have why we are launching here. Sriharikota is our launch pad. Why here we have to put at the edge, nearer to equator. If we have to put at edge, then we have Andaman and Nicobar also. This is Andaman and Nicobar is a better place, less more nearer to equator. Why? Why did we choose only Sriharikota near Andhra Pradesh, Chennai, sorry, Tamil Nadu, Andhra Pradesh border? Why didn't we choose in Andaman Nicobar or the southernmost? Why not in Kanyakumari? Bola. Here to one more point, it's not like that. See, two questions I have asked simultaneously. There is a third point with respect to eastern coast. If something happens, if something happens here, if the rocket fails, the rocket will collapse in the ocean. Okay, here also if it collapses, here also it will collapse in the ocean, but here it is west side, so we are going against the direction of Earth. Why like that? If you're on the eastern side, both will be there. Eastern movement of the Earth will be added, and if it collapses, if it fails, it will fall in the ocean. Here we have not kept in Sri Lanka or Tamil Nadu because, sorry, we have not kept in Kanyakumari or Tamil Nadu region because here you have a small island called Sri Lanka. If we keep in Kanyakumari launch pad, if something happens, it will fall in Sri Lanka. That's the reason, on a safer, higher level, we kept in Sriharikota. Then why didn't we keep in Andaman and Nicobar? Andaman and Nicobar is more because of logistic reasons. See, if you look at ISRO, Bengaluru is there, Trivandrum is there, rockets, satellite, and throughout India, just we saw a diagram yesterday. Throughout India, they are located and they will be reaching. How we can go to Andaman and Nicobar and deliver everything? If we forget one nut bolt also, we have to go back to the main line and get. Scientists will not well. It is because of logistics. Actually, Andaman and Nicobar is easier with respect to gravity. But logistically, it will be difficult because it's a thrown-away island. And safety is also important. If someone comes and attacks in a far, far away land, that is also an issue. That's the reason we didn't keep in Andaman and Nicobar. Okay. Very good. Not only transportation, our logistic cost, that's what we are addressing. So that's it for today. These ISRO centers and all these things we will do very quickly tomorrow. This is yesterday's question. take a snapshot of this. Yesterday I gave the question, discuss the contribution of Indian space program for socio-economic development of the country in various applications: agriculture, renewable energy, forest, governance, land, ocean science, rural development, urban development, water resources, weather, national needs. All these are incidentally remote sensing applications. Remote sensing applications. All are remote sensing applications. All these are. So how this has, obviously soil, renewable energy, all these things studies will benefit the socio-economic growth of the country. So space program has been used for this. And another dimension also for telemedicine, tele-education, varieties of applications. So I'm bombarding you with all these details because we have to learn, na? Village resource center. ISRO will establish many at rural areas. In these rural areas, village resource centers will work. They will provide a connectivity from farmers to scientists. Many things are being done by village resource centers. Education, many things being done. Okay, telemedicine, doctor will be somewhere, patient will be somewhere. Consultation in between, like that. Huh? Disaster management. So all these are incidentally applications of communication satellites. Okay, communication satellites has helped us like this. Remote sensing satellites has helped for all these applications. Okay, like that we have to look. Fine. Take another question. See, we did Chandrayaan quickly. We did Chandrayaan. We did Mars orbiter mission. Understand the question there. Later you can note it. When we did Chandrayaan, to Moon we sent, to Mars we sent. Then why India? I already said that India is very good in space. In spite of so much of advancement in space, why didn't you till now? See, of course, now they are planning, but till now, why didn't they focus on human space missions? 1960s, 1970s, we started our space program. Yes or no? Moon, that man, first step, again to leap to humanity. Again leap towards humanity. Bolke statement was given when first one man kept his foot on Moon, very long back. If so, space is so much advanced in Indian context, why didn't we do humans? Why didn't ISRO focus on human space missions till now? Sir, don't say that, sir, we have Gaganyaan in the future. Okay, Baba, but till now, why didn't focus? Critically, explain critically. Don't simply say technology is not there. Okay, this is not a one-word statement. Okay, so note down this question and write it and send me. People who have taken admission, I will ask. I'll point out from day after tomorrow. I want you to push. I will push you initially. Don't worry. Afterwards, anyway, you will write. Okay. Sir, someone are asking about details of expense course. We don't have re-entry vehicles. No. Write the answer, my dear. I'm not asking you this as you write is a 10 marker. Write this as a 10 marker question. 10 marker question. In fact, this is a previous UPSC question. Similar question they have asked like this. Okay. So students are asking about details of the course. If you see July 16th Telegram channel. July 16th Telegram channel, all the things which it is posted here, SNT brochure will be there. Link also will be there. This Google form also will be there. In July 16th, that posts are there already. It is mentioned July 16th. If you browse back, you'll find in our Telegram channel, Economy by Fazal sir. Okay. So in that, you'll find the brochure and you'll have Google form also, and you'll have payment options also. All the details are there in July 16th only. It got posted. Please see and see because someone was asking. Okay, same number. All the details are mentioned in the July 16th. There is a number given there in July 16th post where you have to do the payment details and all these things. Please see July 16th post Telegram channel. Okay. Fine. Then you will have the details. Fill the Google form also. All are there in July 16th post. Okay. Write this question. I will explain this question tomorrow. See the details, Nagaraju. Oksar chudandi meeru. We have covered many things. Oksar peaceful ga observe cheyandi. It will be useful. Don't worry. Okay. So that's it for today. I don't want to disturb the next class. Take care. We'll meet again tomorrow. Bye-bye. Okay, thank you. Bye, everyone.